Hello, so in today's video, we're going to answer quite a tough question, it looks like, from the 2022 Edexcel uh, Paper 3 statistics exam. So this is the stats section, the statistics section from the Paper 3 2022 Edexcel A-level exam. So we're going to answer this question 5 here. So we've got a company that has 1,825 employees. The employees are classified as professional, skilled, or elementary. Okay, so the table below shows the number of employees in each classification. The two areas, A or B, where the employees live. Okay, so we've got two regions, two areas, A and B, and we've got different levels of employees, so professional, skilled, and elementary employees. So an employee is chosen at random. We've got to firstly find the probability that this employee is skilled. Okay, so this is so the first question is just easing us into the problem. Sorry, let me try and see if I can get my pen tool to work. Let's just see what's going on here. I might have to actually refresh the page. Sorry, give me 1 second. Right, there we go. Right, okay, now let's go back into full screen mode. There we go. Right, so the probability that this employee is skilled. So it's the number of skilled employees out of the total number of employees. So in total, how many employees do we have? So in total, we've got 1,825 employees in total. So it's going to be out of 1,825. And then how many skilled employees do we have? So 275 plus 90, that's going to be 365. So that'd be the answer to question 1. If you really wanted to, you could simplify that fraction. If you do that, you get 0.2. So it's probably actually better just to leave it at 0.2. So 20% chance you pick a skilled employee. Now, part B, what is the probability that we pick someone that lives in area B and is not professional? Okay, so how many people in area B are not professional? So we got 90 who are skilled, 80 elementary. So we've got 170 people who live in area B who are not professional. So the answer to this one, the probability is going to be 170 out of 1,825. Let's just put this on the calculator, see if we get a nice number. No, not really. I mean, it simplifies to 34 over 365 if you really want to write that, but you don't have to. You just write the original fraction that we just wrote back there. So that would be question B. Okay, now let's go on to the next one then. So some classifications of employees are more likely to work from home. Okay, so now we've got people working from home. So we've got 65% of the professional employees in area A and B work from home. Okay, so I mean, let's just try and make sense of this information here then. So 65% of professional employees work from home. So if we look at our professional employees here, 740, 380, sorry, 740 professional employees in area A, 380 in area B. I mean, let's just add those up. Let's get a total tally for this. I'm just going to rub this out here. So let's get a total of people in professional employees. So the total 740 plus 380. So you got 1,120 professionals. If we just go to the skilled ones now, so 90 plus 275, we got 365 skilled. And then elementary, we've got so that's going to be 340 elementary employees. Okay, so that's our tally. Now, again, let's read this. So 65% of professional employees work from home. So the number of people that work from home is going to be 65% of 1,120. So again, yeah, 65% of this 112. So we just do 0.65 times by 1120. Do that on the calculator, 1120 times 0.65. So we've got 728 professional employees that work from home. Okay, so then I'm going to put this actually over here. I'm going to do like an extra column in my table. So work from home. So I just call it WFH, work from home. Okay, so we've got, out of the professional employees, we've got 728 that work from home. Now, 40% of skilled employees in both area A and B work from home. Okay, so again, we've got a total of 365 that are skilled employees. So 0.4, so 40% of that, 0.4 times by 365. Now that's going to give us 0.4 times 365 is going to give us 146. So we've got 146 employees that are skilled that work from home. And now let's look at the next piece of information. So 5% of elementary employees in area A and B work from home. Okay, so we're going to do this calculation, 0.05 times by the total number of elementary employees, which was 340, so 340. And if we do that on the calculator, 0.05 times 340, 17. So you've got 17 elementary employees that work from home. Okay, so hopefully that's going to help us because they've given that information for a reason. So event F is that the employee is professional. Okay, event H is that the employee works from home. And event R is that the employee is in area A, is from area A, sorry. So using all this information, we now want to complete the Venn diagram over here. Okay, so we've got then, so let's look at this H to start with then, working from home. So how many people do we have that work from home in total? So H is the number of people in total that work from home. So let's try and think about this. So in total, how many people do we have that work from home? So we're just going to add up all the number of people in this column here, this work from home column, which is there. So 728 plus 146 plus 17. So if we do that, 728 plus 146 plus 17, that's going to give us 891. So we know that 891 people work from home. Okay, so we got that information there. Now that's going to be useful to calculate get my my mouse back, my cursor. So yeah, we've got two missing parts in this H circle on the Venn diagram. Everything inside that must add up to 891. So we know that, so that's probably going to help us out a little bit. What else do we know? So R is so R represents that the employee is from area A. So how many people live in area A? Again, let's just work out the total for this. So 740 plus 275 plus 260. So 740 plus 275 plus 260. That's going to give us 1,275. So, I mean, we can actually just write the information that we've got down here then. So the number, number of people, I'm just going to, so number, when I say this N, H, this means numbers. So, you know, with probability, we use P and then brackets H, for example. N just means numbers. The number of people in H was this 891. The number of people in R, which again was working from, from area A, so number of people in area A. So the number of people in area A, that was 1,275. And then what else do we have? H, which was working, well, sorry, we just did H, didn't we? Working from home, that was 891 people. And then F is the probability or the event that an employee is professional. So how many professional employees do we have? Well, that's this number here, isn't it? So this 1,000, so this number 1,120 that we worked out before. So just write this down here. So NF, professional employees, was again 1,120. That's 120 there. Okay, so got that data. Now then, okay, so let's start by thinking about how many people are not working from home, are not professional employees, and do not come from area A. So that's going to be everything on the outside of this shape. So how many employees? Actually, no, let's not do that for now. Let's actually work out firstly. I think it's probably a better idea if we actually work out how many employees work from home and are also from area A and also are professional. So to do that, we're going to use our table. So professional employees, we're going to go to this column here. Professional employees who live in area A and work from home. So again, using the information in the question here, 65% of professional employees in both area A and B work from home. So that means that 65% of this 740 that live in area A work from home. So we're going to do 740 times by 0.65. And that's going to give us a 740 times 0.65. That's going to give us 481 people who are professional from area A and work from home. Okay, so we know that in the middle, we've got to have 481. So we can say that the number of people in the intersection of H, R, and F is equal to 481. Okay, so we got that. Now then, we know that the number of people that are working from home, so this H, is got to add up to 891. So in this in this segment here of the H circle, we've got to do on the calculator. So this part here, we've got to do 891 and then subtract 123, subtract 481, subtract 247. We do that on the calculator. So 891 take away 123, take away 247, take away 481. We get 40. So 40 people work from home, but do not live in area A and are not professionals. So we know that piece of information there. So I'm just going to rub out this there. So we've got that piece of information. Now we can do the same to work out the other missing gaps in our Venn diagram. So if we think about it again, we've got, so we know that the number of people who are living in area A is 1,275. So to work out this missing component here, we're going to do 1,275, take away these three components that we have here. So the 481, take away the 123, take away the 412. We do that on the calculator. 1275, take away 481, take away 123, take away 412. We get 259. So we got 259 people inside there. Okay, so we got that piece of information now. Sorry, let me try and write that a bit neater. That should be a 5. So 259. Sorry, 259. Okay, yeah, so that would be that one, but I've messed up my 5 again. Anyway, right, so that's 259. I'm just going to rub out this here. Okay, so we've done, we've not quite done yet because we've got to work out the number of people on the outside of this Venn diagram. So remember, initially, we've got 1,825 employees in total. So what we need to do is we need to do 1,825, take away all of these numbers in here. So I'm just going to use speech marks, all numbers in Venn diagram. So 1,825 take away 40, 123, 412, 481. Sorry, let me get my cursor to show you what I mean. So this number, take away 40, take away 123, take away 481, take away 247, take away 133, take away 259, take away 412, and that will give us, I mean, I'm just going to do this on calculator now. 1,825, take away 40, take away 123, take away 481, take away 247, take away 133, take away 259, take away 412. Have I missed any out? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, so we get 130. So 130 employees do not either work from home, live in area A, or are professionals. So that's our Venn diagram completed there. Okay, great. So we've done the Venn diagram. So then the next part of the question, part D, is we've got to find the probability that someone is not from area A. So remember, this dash there is the complement, so not R. So let's just write this in words so we can just be really clear about what this means. So we want the probability that someone is not from area A, so not from A. Sorry, not from A. So I'm just going to write this again because I want to be as neat as possible, just to give you the just to be neat for you guys. So not from A, and the intersection of not from A with being professional. So what is the chance we pick someone who sorry, I spelled professional wrong. There shouldn't be the F there. So what's the chance we pick someone who is not from A but is a professional? Okay, so if we look at our Venn diagram, we want someone who is not in the, so R, remember, R represents the area A. I don't know why they used R instead of A. It just makes things more confusing. Anyway, right, so we want someone who's not in this R circle. So I mean, if I do like a, let me just do like a red dash line just to be clear. So we want to pick someone who is not in this R circle. so not in A, and also they must be professional, so they must be in the F section. So everything on the outside, so let me try and I don't want to shade things in because it's just going to make things messy. But if you imagine everything on the outside of this shape, so everything on the outside of this red dashed R, so everything on the outside intersecting with everything in the F circle. So where would that intersection take place? So it's going to take place here. It's going to take place with that value there and that value there. So basically, you want to be professional. So you want to be in this F circle. So this F circle represents everyone who's professional. And also, you must not be in the R circle because you must not come from A. So the only two categories in this diagram that are professional and do not come from A together is this one and that one. So again, the only two compartments in this Venn diagram that are professionals in the F circle but not in the R circle are these two here. So what we're going to do to work out this probability is we're going to just add up those two numbers. So this is part, what part was this again? I think this is part D, wasn't it? Yeah, part D. So with this question, we're just going to add up the two numbers. So 247 plus 133, divide that by the total number of people. So the total number of employees, which is 1,825, and that's going to give us the result that we're looking for. So 247 plus 133 is going to give us 380. So 380 divided by 1825, and that's our answer. I'm just going to check if it gives us a nice number. No, it doesn't. I mean, if you want to simplify it, you can simplify it to 76 over 365. But either of those fractions are equivalent, so either fraction would be fine with that question there. Okay, brilliant. Yeah, so let's go to part E. So that's that one. So part E, find the probability that someone is not in the union of H and R. So HUR, that's the union between people that work from home and are from area A, but the complement of that is not that. So we want to pick people who are not in either H or R. So remember, U is basically U, but the union is basically H or U. So we want to pick someone who is in neither H nor R. That's what we want to do. So someone who doesn't work from home, nor is from area A. So that's what we want to do. So we want to think about everything. So if we look at the people that work in both area, sorry, that are from area A and work from home. So I mean, I'll do this in orange. So everyone that is from area A, so the R, this R circle in the Venn diagram, and then H, which is working from home, that's going to be these circles here. So these two circles combined there that I'm doing in orange here. So everyone in this circle, sorry, these two like circles combined, this kind of like can't even think of the word to describe the shape, but this orange shape here. So every person that falls inside these two circles combined, either works from home or is from area A. We want to pick someone who is not within that circle. So we want to pick the complement of this union. So everyone who's not in that region. So that would be, I mean, if I just rub out the blue lines here, the blue circles, just to be very, very clear. So we want to pick basically the people in the compartments outside of this orange region. So that person, these group of people and these group of people. So this probability is going to be 133 plus 130 out of our total, which again was 1,825. So that's going to give us 133 plus 130. We're going to divide that by, well, we get 263 if we do that. So 263 over 1,825. Does it give us a nice number if we do that on the calculator? No, still doesn't. I mean, that's a simplified fraction there. We can't actually get any more simple than that. So that would be part E done. It's done part E. And then the last part of the question, so part F of the question. So we want to find the probability that someone is professional given that they work from home. So let's just again write this in words. So probability that someone is professional given that, so remember this line, this like vertical line means given that they work from home. So work from home. So that's the calculation we want to do now. And just to be clear as well, I'm just going to write this up here with the part E, just in case this one didn't make sense. So this is this one was the probability that you pick someone who neither works from home nor is from area A. So neither works from home nor is from area A. So that was that one there. So people who neither work at home nor come from area A. So that was part E there. But now we're looking at part F because we're now on part F. So we want to find the probability that we pick a professional worker given that they work from home. So remember, this is kind of like this is a conditional probability now. So we've got to use our formula, our conditional probability formula. So hopefully you remember that formula. So sorry, sorry, I just got an itchy throat there. So remember our conditional probability formula. So probability of A given B is equal to the probability of A and B divided by probability of B. So that was our formula. So with this question, we want to find the probability that someone is professional given that they work from home. Okay, so the probability that someone is professional, I'll just say prof for professional because I can't be bothered to write out the full word. So professional, given that they work from home, that's going to be equal to the probability that you pick someone who is professional and works from home. So again, this intersection notation, so professional and works from home, divided by the probability you pick someone that works from home. Okay, so that's how we're going to do this calculation. So firstly, if we go to our Venn diagram, what is the chance that we pick someone who works from home? So, well, how many people do we have that work from home? Let's just count the number of people that work from home and are professional. I'm going to rub out the orange lines again, just because it just looks a bit messy, doesn't it, with all these like dashes and stuff going on here. So we want to pick people that work from home and are also professional. So how many people do we have that work from home and are professional at the same time? So it's going to be people in this compartment and people in this compartment. So working from home is the H circle, professional is the F circle. How many people both work from home and are professional? So it's the intersection between H and F. So it's these two numbers added up together there. So the number of people, so again, I'll use this N. N stands for number. So the number of people in H intersection F is going to be 247 plus 481. And if we add those two numbers up, we get 247 plus 481. That's going to be 728. So we've got 728 people who work from home and are professional at the same time. Okay, so we've got that. And now then, so that's going to help us. So we know the probability that someone is professional and works from home is going to be 720, that should be a 2 there. 728 divided by the total number of people, which is 1,825. So that's the top, that's the numerator. Then we've got to divide that by the probability that someone works from home. So let's look at our Venn diagram. How many people work from home? Well, it's everyone in the H circle, isn't it? So it's, I'll do it in a different color, just to emphasize. So everyone in this H circle, so those people plus those people plus those people plus those people, those are all the people that work from home. So the number of people that work from home, in fact, we've actually already got this down here. If you notice down here, we already did this. So the number of people that work from home is 891. So we're going to divide that by the probability you pick someone that works from home, 891 over our total 825. 1825. Okay, so then what we can do just by using basic fraction facts is keep, change, flip. So flip the second one, 825 over 891. I don't think it was a good choice to choose green as this color because it doesn't look very bright, does it? Sorry, it looks too bright is what I should be saying. Anyway, yeah, so what happens, that will just cancel out with that. And so we're just going to be left with 728 over 891, which again would be your final answer. I mean, let's just see if we can simplify that actually. No, that's our final answer. Yeah, we can't simplify that any further. So that is our final answer to the final part of that question there. So yeah, so that's the probability you pick someone who's professional, given that they work from home. So the probability of F given H. So yeah, quite a tricky Venn diagram question, quite a tricky conditional probability question, because you just got to be careful with these Venn diagrams, but hopefully that all made sense. But yeah, any questions, do leave them in the comment section, or any longer questions that you want specific help with. Again, do drop me an email, doctordifferentiation@gmail.com, or if you do want some one-to-one tutoring before paper 3, again, send me an email and we can set up a session, a £35 session, one-to-one for an hour. So please do drop me an email if you do need any help, and we can get that arranged. So thanks a lot for watching, and again, good luck with your revision.